Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is EV charging and solar opportunities and solutions. This topic is being presented by Sean Silvey, Product Application Specialist, and Adam Householder, Commercial Strategy Manager, both from Fluke. We expect today's presentation to last roughly 45 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Adam to start things off.
Great, thank you so much, and thank you for having us.
Excellent, thank you.
All right, kicking off. As mentioned, my name is Adam Householder. I'm the Commercial Strategy Manager for Fluke Clean Energy Products, and then I'm joined here today by Product Specialist Extraordinaire Sean Silvey, who will be going through all the technical features and benefits of the tools and solutions we plan to present. So I will start off here just with a baseline of some of the electric vehicle charging infrastructure and trends. So just by this quick view, it's expected that EV charging infrastructure is going to be reaching 46 billion by 2025. Much of that aided by federal infrastructure bill efforts. A couple of trends to be aware of. There's a federal pledge to build 550,000 new electric vehicle charging stations by 2030. Several government rebates and initiatives available, both at the federal level, state level, and also municipal level. We're experiencing 70% year-over-year growth for EV sales, and a lot of exciting funding opportunities through the infrastructure bill that I'll detail a little bit more in the slide following. So as mentioned, as we're seeing some of the cash flow of electric vehicle charging infrastructure, last March, we learned of the Electric Highway Coalition. That was a few of the largest utility companies in the Southeast joining together with the initiative to develop charging infrastructure in the Southeast along national highway corridors. And then we saw towards the end of the year, $7.5 billion was designated for electric vehicle charging infrastructure in general. Then we learned towards the end of January about the formation of the National Electric Highway Coalition, which is over 50 of the largest utility companies and investor-owned electric companies across the country, joining in the effort to develop charging infrastructure across the country along major highways. And then we learned that $5 billion of that $7.5 billion is going to be flowing through those 50 investor-owned utility companies. This presents significant opportunities for subcontractor networks who are working with the EVSE manufacturers. So NLX, ChargePoint, Wallbox, Volta, Rivian, several opportunities for the customer at the field level to bid on contracts and get into these companies that are rapidly expanding. Volta, as an example, they're far different from several of the other electric vehicle charging manufacturers. They are free charging to the customer. And the way they do that is by selling their charging station built as essentially as billboards or ad space. So the ads that are being purchased on those charging stations are what pay for the customer. And so you're going to be seeing those pop up at retail locations, grocery stores, multi-unit dwelling homes, all across the country. NLX is another situation where they have multiple business development initiatives out in the field, but one of the things that they do that's really consistent with these other manufacturers is that they require or heavily suggest, in some cases require, the presence of an electric vehicle upon installation of those charging stations. So just trying to lay a little bit of foundation here as to what kind of opportunities are coming out of these large manufacturers. And then you have at the other level, you've got companies like Qmerit, where if a customer purchases an electric vehicle from a dealership and wants to arrange for charging station installation at their home through the purchase of that vehicle, that contractor is most likely through the Qmerit network. So a lot of opportunities as end users are looking for the charging station infrastructure business development opportunities. Many of these brands are going to continue to pop up for you. So what are some of the problems we're seeing out in the field? Limited methods to conduct safety testing and validate the proper and efficient operation of these stations. There are no deep technical solutions in the US market. Most of what may have been seen is a go, no-go type of solution that doesn't provide granular details. And then techs and electricians don't typically have electric vehicles when going out to do these installations or service and maintenance calls. So that presents its own barriers in many cases. And so now that gives me the opportunity to hand it over to Sean, who's going to introduce our solution here.
Thanks, Adam. Let's go ahead and move over to the next slide. So, yeah, as Adam mentioned, it is difficult for these technicians. They typically do not have an electric vehicle out on site, but they still have to service and see if the charging station will be working correctly. Also, as mentioned, this is such an evolving industry right now. Typically, your electricians and your contractors that didn't do these types of roles are now being asked to go out and either install these charging stations or, even operate and maintain them once they're even in place. So Fluke has come up with a great solution for an EV adapter. This is basically a charging station adapter that represents the electric vehicle. They're able to go out and determine if the charging station is working correctly. So as I mentioned before, who's going to be doing this? Well, all of our electricians that are now being asked to run out and do this. These are the same electricians that are coming in through your doors, originally buying other parts, other supplies for other jobs. Now this new role for them to go out. The standards are out there. The IEC 61851 is designed for what is recommended and what they need to comply with for these charging stations. And again, how are they going to do that? By having this type of adapter, they're going to be able to easily run through and work through the vehicle or the charging station itself to see if it's been installed correctly. This unit, in conjunction with either a digital multimeter or potentially a scope meter, is going to allow you to do several functions of the charging station. You're going to be able to check if it's grounded correctly, if the ground fault works, the GFCIs work. You can do insulation tests as well. But the validation and verification that the voltage is working correctly, that the control signaling is working correctly as well. All of this can be done through the FEV 100. Let's go to the next slide, Adam. So again, what's in this? As you can see here, this is what the adapter looks like. It basically can run through and very quickly go through and do ground pre-checks to make sure that everything is grounded correctly. You can do a control pilot simulation, just like if a vehicle wasn't connected to it. You're able to do a ground fault, any error notification on that. Obviously, all of these units have a GFCI that's built into it for safety. We can test that as well with this device. And then with, again, in conjunction with a DMM or a scope meter, you're able to actually see the waveform output, what the voltage looks like. any loop impedance, or any resistance. Let's go ahead and move to the next slide.
Hey, Sean, I'm going to go ahead and pop into the FEV introduction video so our viewers can see a little bit of what we put together here.
Hi, I'm Marco from Fluke. As electric vehicles have increasing popularity, the infrastructure to charge them is also expanding. Hence, maintenance and reliability of chargers are critical for operators and also for owners of stations. The Fluke FEV 100 station test adapter simulates the presence of an electrical vehicle and enables you to test the functionality and safety of an AC Level 2 chargers easily and reliably. The Fluke FEV 100 connector accessory is your interface for Type 1 socket outlets or J-plugs on a Level 2 charging station. Let's see how it works. First, connect the FEV 100 station test adapter to the charger's Type 1 connector and check that the station is correctly wired and secure. Make sure that protective earth is functioning properly using the PE pre-test safety feature. Then, connect the multimeter. It's recommended to use a Fluke 87.5. Check the output voltage and measure the continuity of the PE connector. You can also test GFCI trip time and leak current. Troubleshoot and simulate control pilot and PE errors through the simple press of a button. Check if the charging station cuts off the output voltage for each error separately. For more in-depth measurements, you may also want to connect a Fluke scope meter. We always recommend to use a Fluke 124. The Fluke FEV 100 has an IP54 protection rating, so it performs in dusty and wet environments. Learn more about your complete EV testing solutions at fluke.com.
What a great video, because it really does. Marco walked through very simple and easy steps to work through and determine that the charging station was operating correctly. We did recommend having an 87 meter. The reason why for that is because of the duty cycle application. You can go in and make that measurement and see what your output signal looks like with that. So that's why we recommended that unit as well. But you're going to be able to check basically if it's a level 1 type of connector to where it's 120 volts. We can run through with the DMM and the test leads and validate that the voltage output looks correctly on that. If it's a level 2 or a type 2 one where we've got a 240 volt, again, we can determine what that voltage looks like. We can validate that the voltage is correct, that the GFCI internally is working correctly. We can even validate if the current output looks correct based on our duty cycle and what that looks like with one of these scope meters. You can do an earth ground verification. And then as mentioned earlier, you can get in with the scope and do control pilot and signal analysis and determine what that signal looks like based on your duty cycle. You can determine what that charging output current should look like. This is an incredible meter because it really does save a technician half the time to go out there. Basically it's half the manpower, because a lot of times these techs have to go out with 2 technicians to go out and try to service several charging stations in one location. So it quickly and rapidly allows them to lose half the manpower, and they can go about 8 times faster because they don't have to disassemble the unit. They don't have to have an EV vehicle in front of them to do it. I believe we also have another video on this as well. Am I correct?
You are, sir. Pulling it up now. We have a video on how to test the station itself. So
The The Fluke FEV100 EVSE test adapter simulates the presence of an electrical vehicle to enable you to test the function and safety of an AC Level 2 charging station. The test cable is the interface for cables of stations that have a Type 1 plug. First, perform a pre-test grounding safety check to ensure the charging station is correctly wired and safe, and that the protective earth is functioning properly. No LED illumination means everything is working correctly. The control pilot switch allows simulations of various charging states. For output voltage, turn the switch to charging mode, position C. Connect an 87.5 multimeter to the L1 and L2 end terminals to measure output voltage. The L-phase red LED will illuminate. You should see approximately 240 volts on the multimeter screen. This is the corresponding voltage energizing the station, the sum of the voltages from each phase. Simulate errors like an interruption of the protective earth system using the PE error button. The voltage supply is cut off and then restored. You will see this indicated by a colored light on most charging stations. Test the station's GFCI system with the GFCI testing function. Once the green ready indicator is lit and the station is in state C, press the GFCI test button. The charging station will display an error and will terminate the voltage transmission. This will verify that the GFCI is operating properly for protection against electric shock. Simulate a CP error by pressing the CP button. Check if the charging station cuts off the output voltage. For advanced testing, use a scope meter. Connect it to the CP signal output terminals of the charging adapter. Turn the switch to position B. This simulates connecting an electrical vehicle. The connector is now locked. A pulse width modulation signal appears on the scope meter. Check the charging modes and duty cycle. Then, return the CP switch to C. The signal can now be visualized at its frequency. The charging station manual should provide voltage levels and frequencies of the different control pilot states. The Fluke FEV100 EVSE adapter lets you test the functionality and safety of electrical vehicle charging stations easily and reliably. Learn more about your complete EV testing solutions at fluke.com.
You know, the video is actually very short in a sense, but how quickly, though, a technician can go out and do it. I mean, within minutes, they were able to validate what the charging station is doing, and can determine if the charging station is operating correctly. I just worked with a company out in Las Vegas, and they were having issues. They didn't know what was going on. Was it the vehicle or was it the charging station? And by taking the FEV100 out, they were able to actually determine that the charging station was working correctly, and there was a communication error going back to the vehicle, which then allowed that customer to get the vehicle serviced. So we identified what was actually happening. So it's an incredible tool to allow you to do all of these verifications with this type of unit. Again, the unit itself on the FEV100 will come with the adapter and with the handle. And again, this is for type 1, level 1, and level 2 charging stations.
Thank you, Sean. And this is also for JPlugs, the SAE J1772. We will have a Tesla Connect adapter soon to go with this solution. So we will have a full level 1, level 2 solution. Currently, this set as is just the J1772 plug. Another thing that we're also seeing in the field with a lot of these charging station manufacturers is that because there isn't a great field solution to test and diagnose these stations, that much of their process is currently to repair, buy, replace. And so when there is a better solution out in the field to do those testing and measurements, we'll see much more service and maintenance happening in the field rather than replacements. Right, moving on.
Great comments, brother. So now we did a great solution with our FEV 100 and our EV charging. So let's now move over into our solar tools and what that would look like. Solar has also taken off incredibly. As you can see here, the trends are just outstanding. More and more people are getting into solar. Literally 46%. We can account for 46% of all new electricity generating charging. Side note, even though Texas is ranked top state right now, they're really taking off. Texas is really taking off in that aspect of more and more charging, more and more solar is being installed. Recently, I read an article in California, and for 15 minutes last week or the week before, they could validate that the whole entire state of California was able to run on renewable energy for 15 minutes. That is an amazing amount considered the amount of people there, the amount of industry happening. So that's really, solar is taking off. It's got a 7% year-by-year growth, but just it's an incredible amount. There's a lot of applications when we talk about solar. They're all very basic, depending on the size, but all of them have to have the solar panels. They have to generate that electricity, that DC charge. Now, some of these solar panels will have an inverter built on the back of them. Typically, those are designed for residential and light commercial, but a lot of the heavy commercial and utility level will go from the solar panels into a combiner box that will combine the voltage and combine the current in this combiner box. And then from that point, depending on the level, they may have battery backup storage, which is a great supplement to the grid when there's high demands in the system. They don't have to technically turn another turbine on. They can supplement through an instant battery dump into the system. But it can go from these combiner boxes and then basically goes into your inverter box. Once it goes into the inverter, it's going from that DC to AC application. Typically that will be stepped up with some type of step-up transformer, and then out to our substation and out being transmitted out into the system. There's a lot of different roles and a lot of different aspects moving from just that solar panel installation all the way up until we get it finally out back onto the grid. Let's go ahead and move to the next slide. So let's look at a typical residential solar system. Now, as I mentioned before, you're going to have a set amount of solar panels. Now, these are typically roof mounted. They've got the roof racks on that. Some are ground mounted, depending on the location and if that's even possible. But once you have all of your solar mounted system, again, as I mentioned in that workflow prior, all of this is either going to go into a combiner box or just go directly into some type of inverter, which then would be either some residential places do have battery backup. I've seen that in some just go back out onto the grid. But there's a lot of information as they commission this. There's a lot of different testing that happens. There's a tremendous amount of connections that's going to be going through as well. That technician is going to be making multiple test points to determine what the output is on that. There's hundreds of tests that have to be collected. All of this then goes back into the reporting aspect that they sized it correctly. The output of the panels are doing exactly what they're doing. And what's nice about the residential and even the commercial aspect side of it, the homeowner can get an interface to see what's happening every minute if they want to, of what their output looks like from their system. But again, the technician has to go in and check that to make that work and to confirm that the system is working correctly. When we get into larger commercial aspects as well, our voltages step up also. We go from a 600 volt rate system, typically with a residential and light commercial, Once we get into these larger commercial, we can step up to 1,000 volts, if not even 1,500 volts. The scale gets larger. We have larger panels, larger systems, which require larger inverters, typically larger battery banks as well. Again, there's still an incredible amount of wire management tests that have to be maintained. They're collecting a lot of the results prior to that commissioning to get that out. Again, this is going back to that customer reporting, so they can determine, you know, this is an investment that a lot of times between residential and these commercial, they're investing in this solar to help either supplement their own energy demand, or they're just getting a rebate to where I've given back into the system versus what I'm purchasing. And if we can go on to the next slide, you can see that on a utility scale, the systems have gotten even larger. These are all ground-mounted type systems typically. We're working with larger amounts of voltage, always within that 1,000 to 1,500 volt range. The CAT rating as well has changed on this. This is category 3. So in that safety environment with the technicians going out there and working in the field, they have to have the right tool to be able to do this. This picture is a very simplified explanation, but all of these panels are hooked up and they're all going to several combiner boxes. And all of these combiner boxes are then tied in. You could have 10 combiner boxes all going to one inverter, or the battery bank system to then one large inverter. Some of these large 1,500 volt inverters are the size of a VW bus. They're incredibly large. They're producing the systems are producing a lot of energy, a lot of voltage, which then steps up and runs through that inverter, going out to a step-up transformer and out onto the grid. I mean, it is literally connected, hard connected to the utility itself and out onto the grid. With these types of applications, there's a lot of commissioning that takes place between the wire management and everything being set up, the environmental concerns that need to take place as well, any safety hazards on that aspect, and then confirming that everything was wired correctly, insulation tests were done, grounding was accomplished, all on that safety aspect. And then we have our operations and maintenance that easily goes into effect on these types of systems. So a lot of documentation has to be maintained in order for these to be commissioned and then finally out onto the grid and being utilized. Let's go ahead and move to the next one. So with solar, there's a tremendous amount of jobs that have to be accomplished. As I mentioned before, you have a lot of solar panels that are being connected and hooked up on these ground mounts. There's a tremendous amount of wire connections and terminations that have to be determined and analyzed. Ground faults could happen if these are not connected correctly. We're getting leakage current going back into the system. Making sure your wire management and all your wiring harnesses look neat and bundled, because environmental stuff can now take place. You could have animals, you could have other just issues happening with just the wiring from the solar panels themselves. So they've got to go out every year and maintain these panels. If the panels are dirty, that loses consumption on the system. So we have to make sure that everything is clean and appropriate to get the best output out of these systems. Now, when I also mentioned too, some of the systems are on roof mounts, we've got to go out and make sure that nothing's damaging that, and that we don't have any water penetration or any of the weather sealing that are causing any effects. So again, another job that has to be done out there. And then finally on that aspect, just maintaining if they have a battery system. Again, these batteries are being charged for either that event of that they're going to backfeed into the system during peak demands. And so we need to make sure that the batteries are working correctly, that they're ready to go. There's a process to determine using our tools and using just their basic workflow, that they need to make sure that the electrolyte's ready, the charge is ready, and if they need to replace it if needed, just to be on the side. So some of the common pain points that we've talked about, there's literally hundreds of thousands of test results that they need to collect. The technicians, it's hard to find some of the root cause of these, which can be a big drag, especially when you have these larger systems. You've got to run out and go through and check all of these connections. And there's a lack of great multi-purpose tools to be able to go out and do it. If you can imagine, some of these large sites are on acres of land. That technician has to carry a bag and tools around and his PPE when he's going out and determining where these faults could be. As I mentioned also before, they need Cat 3 tools being in that outside environment. And if they are in that 1500 volt range, they need to make sure they have a Cat 3 1500 volt tool. Now, different clients require different results or different reports. There's different systems out there, different formatting. So each one of those, they may have to adapt a new type of report to that site just for reporting purposes. Key thing is that unplanned downtime. You know, we've designed these systems to get optimal energy out of them. Any unplanned downtime, we've got to get out there quickly and get that resolved so we can get that system back up and running. And the key thing on this too is that, you know, technicians got to trust their meter. They have to be able to trust the meter that they're working with, that it's accurate and being able to do it, because again, safety is the key thing out in these environments. Sometimes it's typically a 1 or a 2-man team during the operations and maintenance. So safety is key, being able to be out in that environment. So let's go ahead and now talk to some solutions on that. So with a Fluke 393, this is our first 1500 volt Cat 3 rated clamp meter out in the environment. This is going to allow that technician to work on solar panels, the combiner boxes, and those inverters boxes. This unit has a new jaw design. This is going to allow them to get into some of those tighter combiner boxes, which is going to be key. They're going to be able to do more analysis, being able to get in on these tighter spots. Now also too, this unit is IP54 rated. Being out in that environment, we want to have tools that are water resistant and dust proof, again, because they're going to be out in the elements trying to solve and correct these problems, or even during these installations. But this meter has even more for it. It's got DC polarity indication, which is a visual that comes out on the screen. It's got a visual polarity as well. So these are two great points. If it's windy, they're working in these conditions, typically they can't hear an audible noise coming out of the meter. They can now see that on the display. Also too, this meter has a DC power, where we can clamp around a meter, clamp around a conductor and make a hard connection with our test leads. We can see what the DC power is coming out of a combiner box or coming out of a set of arrays. Now this unit's going to be perfect for your solar technicians, those installers, but it's also going to help the electrician and those designers going out into the field. And then always your operations and maintenance, those techs are going to be needing this type of meter as well. Now this meter does come with a kit. You can order it with a kit, which is going to come with our MC4 cables. These are going to allow the technician to go out and either isolate a single panel, or they can do a series in the whole string and see what the output is looking like on that voltage. And I believe we have a video on this one, do we not, Adam? Yes.
Coming right up.
The future of power needs tools that are up to the task to keep you safe in harsh environments. Introducing the world's first and only Cat 3 1500 volt true RMS clamp meter, the Fluke 393 FC clamp meter, designed for higher voltage applications. The Fluke 393 FC clamp meter and test leads provide enhanced safety for you and your team in Cat 3 environments like solar installations. The audio polarity indicator enables you to ensure PV panels are installed correctly. The thinner jaw is ideal for cramped spaces like combiner boxes or inverters. And Fluke Connect lets you view, share, and save measurements from a safe distance. DC power measurements, voltage and current. The Fluke 393 FC does it all in one. Safely, ruggedly, and reliably with an IP54 protection rating for dusty and rainy environments. The Fluke 393 FC, the world's only Cat 3 1500 volt true RMS clamp meter. Visit fluke.com to find out more.
Perfect. Yeah, so again, this is the world's first Cat 3 1500 volt clamp meter. You're going to have technicians in your facilities that are needing this type of tool. We need to educate them that, you know, that Cat 3 rating is all on those outside environments. That's what the category rating is now on a safety level. Again, just remember that thin jaw, that IP54 rating, being able to get into those tight combiner boxes, the DC power, the visual polarity, the visual DC polarity, just an incredible tool in the palm of their hands. Now let's move over to doing some service on the array, on the panels themselves. We have our radiance meter here, the IR1. This is a 4-in-1 tool for being out in the field. This is going to allow that technician to determine what the solar radiance is looking like on that panel. They're also going to be able to determine what the temperature of the panel looks like on the top of the surface and just as much on the back side of the panel. These are two characteristics when they're looking at the output of the panel and what the performance looks like. Now also too, this is going to allow you to do your array orientation. And what that means is it has a built-in compass to the meter. They're going to be able to determine what direction the panels are facing and get the appropriate output of the sun as well. And then finally, the tilt of it is going to play a key role as well on what, again, that all plays into your solar radiance, what the temperature looks like. These are all key features that a solar technician is going to need when they're out there in the field. Again, this is going to be working with your installer, your electrician, but also your operations and maintenance are going to need something like this as they continue to go out as panels degrade. They're going to be able to see what the output of that looks like. I think we also have a video on this one as well, Adam.
If you're surveying, installing, executing maintenance, or checking performance of solar panels or a photovoltaic system, the Fluke IRR1 Sol Irradiance Meter gives you the 4 critical measurements needed all in one easy-to-use tool. With the Fluke Irradiance Meter, you can make instantaneous measurements to determine the watt per square meter solar irradiation. Measure the ambient temperature at the panel easier and faster than ever. The Fluke IRR1 Sol is the only irradiance meter that can take the temperature without needing an external probe. This is enabled by innovative Fluke technology, which embeds an integrated conductive temperature sensor in the meter. Temperature can also be measured with increased accuracy with the external temperature probe. A built-in compass enables you to measure and document roof or site orientation. An inclination sensor lets you know the solar panel tilt when surveying, installing, or adjusting the installation. The Fluke Irradiance Meter is robust, rugged, compact, and ergonomically designed so it fits comfortably in your hand. The high contrast LCD and large readable numbers make the screen easy to see even in bright sunlight. It comes with a convenient carry case with shoulder strap. Get all the critical photovoltaic measurements needed to install, verify, and report on the performance of a photovoltaic system in one easy-to-use instrument. The Fluke IRR1 Sol Irradiance Meter. Find out more at fluke.com.
You know, this is an incredible tool. I mean, 4-in-1, it's literally like the Swiss Army knife when it comes to all the functionality that a Swiss Army knife can give you. This irradiance meter is that same type of tool. It's really taking 4 tools and putting it into one to give really that complete capability of doing that installation from the get-go or identifying later on in your operations and maintenance if that system is working correctly. Let's go ahead and move to the next slide. So now I'm going to talk briefly. We've got some more slides to go through. we've gone through and talked about the voltage and current and everything that we can do on the output of those panels. We can talk about the irradiance, but these systems take so much more into it. Thermal imagers are a key tool to visually look at those panels to make sure there's no fracture cracks in them. You can look and see if the diodes have even been blown out on them. So having a good type of thermal imager is going to really help them out in every aspect of that solar system, whether it's at the panels, at the combiner boxes, your inverter boxes, even on your battery storage. And then even when we move up even more to that, to your substations and your transmission. But having a good thermal imager is going to allow that. Now, also mentioned too, they need a DMM. The 875 Max is an IP67 rated digital multimeter. This means that this thing is dust proof, shock proof, waterproof. It's just an incredible type of tool. This is going to allow them to work on the VFDs. It's going to allow them to work on those residential and commercial systems that are going to go up to 1,000 volts. This tool also comes with a kit. So you can get this unit and with our MC4 connectors, that PV lead 1 and that PV lead 3 is going to allow them out in the field to make several measurements. So that's a key one on that. Let's move to the next one. Now, battery application. We've talked about it several times on this. Those battery banks are going to be from the time that they install them to the time they're commissioned out. We need to make sure that those batteries are working correctly. The BT521 is that perfect tool for that. They're going to be able to determine what the voltage and resistance and temperature of those batteries look like. They are going to be able to log those and have that also in that system for that reporting capability. It's an incredible tool for that operation and maintenance team. Now, we mentioned scopes. Again, the scope is going to allow them to do an output on those combiner boxes if they need to, especially the inverters, and even into that substation and transmission. Again, a scope is going to allow you to look at that waveform. So if they're really trying to isolate and determine if an inverter is outputting correctly, this is the tool for them. Being able to do that waveform, capture that voltage. We definitely want to get them thinking about having a scope in their truck for those solutions. Next is now we're going to talk about power quality, and there's several power quality units that are really key for this. The Norma 6004 unit allows them to not only analyze the output of the inverter, but you can do DC with this unit as well. So having that capability to determine what the DC input looks like, as much as that AC output of that inverter and of that system. A lot of problems happen. It's not necessarily on the DC side of it as much as it can be on the AC side with transient, any issues on that hard connection to the step-up transformer and out onto the grid could literally be back feeding into that smart inverter, and then from that point tripping out that system. So talking to them, having some type of power analyzer, this is going to allow them to determine any transients or any issues on that. Let's go our next one. Now the 1777 is an incredible tool on that AC side. Being able to look up and see on harmonics, transients, again, that capability on the AC side and determining what that output looks like. And this can even go farther, even after the inverter. You could be doing these types of measurements through the step-up transformer just to determine that the transformer is also working correctly. Let's go to the next one. And then finally on these, our 1748 is an incredible power logger as well. Being able to get in and then quickly look at any unbalance, if there's any harmonics on the system, any changes in those voltages. Again, these are all solutions when we talk about these solar systems, from the thermal imager to the irradiance to our power output with our PQ units, the clamps and the meters, being able to do that voltage and current analysis as well. And then, talking about our battery analyzer. Now let's go to the next. And now with all of these connections, part of the commissioning aspect is to do insulation tests. So having some type of tool like a 1555 is going to give them the top end voltage output that they need to validate that those conductors have been installed correctly and that we don't have any insulation breakdown within that system. But this is also part of that reporting capability, and having the 1555 FC gives them that opportunity to grab that data, put it into their reports, and determine that the insulation tests were done correctly prior to commissioning. And then finally on this, on our applications, an II-900 or a 910 is going to allow them to analyze if they have any substation or transmission issues. We've really walked through the whole process of the solar installation, from the panels themselves or what they need with the irradiance meter, all the hard connections, having the MC4, moving through that through the combiner boxes, the voltage, the current, any of the insulation that they need to make those hard connections in the ground, analyzing the inverter, any output with the power on the power quality side, our battery analyzing, and finally that next step, getting into the transmission aspect of it, and if they're having any problems with that, which could cause backfeeding into the whole entire system. So Fluke has really offered a total package of solar solutions out there in the field from a multitude of whatever level of technician you are, that solar installer, all the way to the operations and maintenance manager. And then finally on this, they're going to need accessories on that. Like I mentioned before, they could be walking around on acreages of land. So having some type of backpack, being able to carry all of their tools into that, whether it's the Pack 30 backpack or even our new our TB25, the tool bucket. And just remember too that meters are one thing. They also need the insulated hand tools to be able to safely work with all of these voltages. So talk to them about that full package of the meters, the backpack, the hand tools, the PV leads that we talked about, these MC4 connections. And I can't put an honor out there on our AMP Probe HD160C. This was really the first solution, and it is still a solution out there to do the 1500 volt DC capability. The AMP Probe unit has been tried and true with a lot of our inverter manufacturers and solar installations before we've now gotten into that double capacity of a clamp meter, giving them voltage and current. And then finally, we also have some great resources for everybody out there in the field. We've got our solar energy resources. If you need information on our irradiance meter, the clamp meter, and even our FEV 100. And then finally, too, we've got some vertical brochures as well. You can easily download from commercial and residential solar, that utility scale, electric vehicle charging, and then even that utility testing tools.
Great, thank you, Sean. And now I'll bring Christina back.
All right, thank you, Sean and Adam. That concludes our presentation portion of the webinar. We'll now move on to the question and answer session. Just as a reminder, if you would like to ask a question, please send it through the question box in your webinar controls. Let's move on to the first one. It says, hello team, do you offer a solution for CCS1 and CCS2?
Not at this time. That is the connector adapter that I was alluding to earlier. So we currently do not have a CCS connector solution at this time, but it is very near, and you'll be hearing about it soon.
Okay. And the next question, why would I need to measure duty cycle on an EV charging station?
Yeah, I can definitely answer that. So By measuring the duty cycle of your EV charging station, you're able to determine what the voltage output would represent for the vehicle. Typically, when you're connecting a vehicle to the charging station, it identifies the capacity of what the batteries can handle. So this, by doing a duty cycle measurement, we can determine what the charge of the charging station, and that would determine what the voltage or basically the current output would look like back to the vehicle.
All right, thanks, Sean. And the next one, how could I use the FEV 100 to analyze the control pilot signal?
Yeah, I can also answer this one as well. So basically what you would want to incorporate is having some type of scope meter like we showed in the video actually. And this would allow you to determine basically your analysis of the control signaling coming through that charging station. Typically, you're going to see a square wave on that type of system. It's not really a sinusoidal AC wave. So that the video was a great representation of that as well, to be able to see and determine if you have any hiccups in that signaling.
All right, and another one, why have people referred to the IRR1 as the multi-tool for the solar professional?
Adam, you want this one or you want me to?
Is a pet project of mine, so I will absolutely hop onto it. Yeah, we called it the irradiance meter because that was the biggest measurement that was being looked for that solar technician at the time that we were developing the product. We kind of hurt ourselves in that naming mechanism because it is a multi-tool, and so when we tell people that yes, this irradiance meter does measure irradiance, but it also does orientation azimuth. It does tilt, incline. You can measure the temperature of the panel because there's an optimal temperature range for every panel to provide the most efficient energy out of it. And that's what everybody's job is, right? And so Sean hit it earlier. People will either call it the Swiss Army knife of solar, or the Leatherman of solar, the Gerber. But true, this is multi-tool. It does 4 things, so you can eliminate 3 other tools, or the necessity of those 3 other tools.
All right, thank you, Adam. All right, that concludes our time for today. As we mentioned in the webinar invitation, Fluke will be giving away a free irradiance meter to one of our lucky attendees. We'll be holding a random drawing after the webinar, and if you're chosen, you will be notified directly from Fluke via email with further instructions. If you have any additional questions or would like to find out more about Transcat's products and service offerings, please contact us at 800-828-1470 or on the web at transcat.com. I want to thank everyone for joining us today. We hope you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Adam, and thank you, Sean. It was very informative today.
Thanks for having us.
Thank you. Bye-bye. Have a good day, everyone.